Hi. Okay, well, I would like to welcome everyone to what is my first experiment with live streaming, and I hope that it will be interesting for you. And I hope we don't have any technical hitches, but it is my first time. Okay, so what I'm going to do today is first of all say welcome to Roots Tech. I hope it's been interesting for you so far. I'm coming to you live from Swansea in Wales, and I wanted to just say you might want to maximize your video window because I'll be showing you some demonstrations on screen. So in order to see what I'm doing, you might need the window as big as possible. And there is a live chat. I don't know how many people are here or whether it will be used much. I personally won't be using it because it's going to take every ounce of my attention to focus on presenting. Okay, but feel free to chat among yourselves if you like. So the first raft of changes that I made recently and updates to DNA Painter were with the What Are the Odds tool, also known as Watto. And I'm not sure if you've used this tool before. To refresh your memory if you haven't, what we're looking at here is a tree, and it's a tree that someone called Karen has built. Now, Karen has got a genealogical dilemma. She has a research question, and that is she wants to know who her father was. She has an unknown father. And what Karen has found out is that she has a DNA match with someone called Polly. And Polly is someone she shares 374 centimorgans with. Now, she's done a bit of work. She's looked at some other shared matches. She's talked to Polly about this, and she's managed to build out Polly's tree. And so she's got a couple of people she thinks might be her father. These are males who were born at the same time. So this is a kind of a typical use of What Are the Odds, if you like. So here are some things that I've changed with What Are the Odds, and here's how you can use them. So the first thing you might see is that the top hypothesis, which is that Karen's father is in this position in the tree, or so that Karen's father's here, and that Karen is here, it now has a little tag that says strongest. And so that is so that you can see easily what the top score is. It's worth reinforcing the top score in a What Are the Odds tree isn't necessarily the actual truth of it. It may be that the place where you actually belong in a tree is not the place where it was most mathematically likely that you would belong. But that is why that strongest thing is there, just so that if you have lots of hypotheses, you can hopefully see what the top one is easily. So the second new feature I've introduced is that you can color code people within a What Are the Odds tree, which isn't something you could do before. So, for example, Kenneth is one potential father. If I hover over him and I go to Edit Details, and I scroll down slightly there, I can choose a color for him. So if we make him yellow, and we select that color, I can also apply that color to all his descendants if I want. And now Kenneth is yellow. And then I might go to David, and perhaps I might make him blue. So if I select him, I can do the same here. So this is a nice way of kind of color coding the branches, just to make it clearer for you to understand what you're looking at, but also to potentially make it clearer to those who you might ask to help you interpret the results. Okay, so that's color coding. Now I wanted to show you dragging and dropping. So one of the frustrations that people have had is that they've entered data into these What Are the Odds trees, and then they can't change the order of siblings, or maybe they had a whole branch in the wrong place and they want to move it, but there wasn't previously a way to do that. So now there is. If you go to the top right, we have a new little option here called Settings, which is, of course, tantalizingly could be the home of lots of new features I add in future. But for now, we have just one feature here, and that is drag and drop to move and reorder. So if we check that box, now we can drag people to different positions in the tree. So, for example, maybe we made a mistake and Polly wasn't actually Dean's grandchild. Perhaps she was the child of Louise. So I can actually drag her and I can drop her in here, and she becomes Louise's child. And you can see that the hypotheses have updated. This hypothesis up here is no longer possible if Polly's in that generation. And we can also reorder the children. So maybe actually Dean was born before Catherine. So we can drag Dean above and pop him there. And then once we're finished, we can uncheck that box. And now we're back in edit mode. Okay. And just to refresh your mind on how this works, say that Stuart had tested, we could add some centimorgans for Stuart, and maybe Stuart ended up being quite a big match for Karen, 786 centimorgans. That obviously would change the picture. So things change as you add more and more data, and the more data points you add in what are the odds, the better. All right, so that is what are the odds. Let's move on to the next item that I've made a change to, or next new release, and that is something called the Shared Centimorgan Investigator. Now, this is actually something I worked on 18 months ago, a long time ago. I was working with a scientist called Amy Williams, who is a geneticist and also a computer scientist. And we got talking. We met at the last Roots Tech that I attended in person in 2020, and we got talking about lots of different things. And this is one of the things that she had some ideas about, and then I had some of the things I wanted to do. So I want you to describe a scenario for you. If we imagine we've got siblings, at least 2 siblings, but actually as many siblings as you have is great, but we don't have either their parents tested. This tool enables you to take the segments that each of those siblings might share with a match, and then figure out which of those centimorgans and those segments that the siblings share with a match are actually distinct. Let me tell you what I mean by that. So if we look at these segments here I've got in this graphic, on the left here we've got the segments that sibling 1 happens to share with a match. So if we call that David, I don't know. And then if we look over here, we've got the segments that sibling 2 shares with that same match. And if you look closely there, you can see that some of those segments are the same. So they've both got this segment that starts on 240 million on chromosome 1, but lots of them are different. There are some different segments on chromosome 1 that this person's got. This person's got a big one on chromosome 4 that this person doesn't have. And what I wasn't able to do before collaborating with Amy was figure out how to actually mush this together and figure out what the distinct centimorgans between those 2 siblings were. And what Amy did was help me out and provide a concept called minimal viable genetic maps. And to cut a long story short, this means that I've been able to create a simple database table where I can do a lookup and figure out the centimorgans for any arbitrary chromosome start position and end position. And that, of course, is the subject of a different tool at DNA Painter called the CM Estimator. But back to this tool, the idea is that we've got this data. So in this case, we've got the data for these 2 siblings. And what we want to figure out is how much their parent might have shared with this match. So if we go back to the tool, here I've copied and pasted that data into the tool. So we've got the segment data that one person shares with a match in the top form field, and we've got the segment data that the other sibling shares with a match in the bottom one. If you're not sure where to get this segment data, there's a link here that says how to get the data, and that takes you to a page at DNA Painter which describes how you'd get that from all of the different testing sites. And then what this does, if you click Estimate Shared CM for Parent, it's just going to do a calculation for you. So first of all, it's going to get the distinct segments from those 2 siblings. And then it's going to apply some very simple maths. So there's a formula, which I'm not going to attempt to recall right now, but it's quite a simple formula that's based on the number of siblings. And so the result of that formula is that typically 2 siblings will account for 75% of each of their parents' DNA. So literally what I'm doing here is just taking that maths. We've calculated that between those 2 siblings, there's 197 centimorgans that are distinct. And then so we're estimating that the shared centimorgan that the parent would have shared with that match is therefore 263 centimorgans. Now, that's slightly crude with just 2 siblings, but it does work quite well. If we add more siblings here, we can refine that even more. So I'm just going to click add data for another sibling here so you can see how this works. I haven't actually got any data handy, but I wanted to show you what you can do. Say there was another sibling who tested, and in fact they didn't share DNA with a match at all. Well, that's useful information because 3 siblings would normally account for even more of the parent's DNA. So if we add this other sibling, but we say they don't share any DNA with a match, and we click Estimate Shared CM for Parent again, we'll see that that number has changed now, hasn't it? So it's still 197 distinct centimorgans, but now the estimate for the parent is 225. And that's because for 3 siblings, we would typically expect them to account for almost all of the parent's DNA, so 87.5% of the parent's DNA. So that hopefully gives you an idea of how this can be used. Now, you might be a bit like, well, so what? The idea is that it helps you to figure out which matches might be worth you pursuing more. So, for example, say that those 2 siblings had happened to share completely different centimorgans with the match, then in that case, the estimate for the parent would be much higher. And you wouldn't necessarily be able to see that at a glance by just looking at the segments. But on using this tool, you would be able to. And the other thing it does is it shows the extracted segments. So these are all of the distinct CMs of DNA, which the siblings share. And you can actually copy and paste that and put it into the chromosome map. So say you're starting a chromosome map for the deceased parent, you could use it there. And the other thing you can do is show possible relationships for 225 centimorgans. And you won't be surprised to hear that I'm doing that in the Shared Centimorgan project tool, another cornerstone of the DNA Painter website. So in this case, we can see what the estimated relationships are for 225 centimorgans shared. Okay, I think that's all I had to say about the Shared CM Investigator, but I hope you find that useful. It's available, it's a free tool just within the tools section at DNA Painter. Okay, what have we got next? We have got a map of clusters. Now, this might be of interest to certain viewers in particular. Something occurred to me recently. So the company Genetic Affairs did a collaboration with GEDmatch where they launched the auto segment and auto kinship features within GEDmatch. I think they're tier 1 tools at GEDmatch, so you have to have a... sorry, I'm just making sure my monitor doesn't turn off. You have to... subscribe. I think you can pay $10 for a month, but you can do it just for 1 month. But then you have access to some quite powerful clustering tools. And something I collaborated with Everett Young at Genetic Affairs on at the end of 2019 was a tool called the Cluster Auto Painter. Now, recently I used the Cluster Auto Painter at GEDmatch, and one of the brilliant things about having it at GEDmatch is that if you are lucky enough to have a parent tested, you can then run this cluster software on your phased kit. So that means I can get a set of clusters just for my maternal DNA or just for my paternal DNA. So I did that, and I used the Cluster Auto Painter tool and I imported it to DNA Painter. But then I thought, well, this is annoying. I know that all of these groups and these clusters are maternal because this was run on my maternal phased kit, but I don't want to go through all of these groups and edit them to be maternal. That's annoying. So I went into the settings and I created a new function which is under actions, and that just means with a couple of clicks you can just make them all maternal, for example, in one go. So if I click on this, it's going to change everything to maternal. It just warns me first, and then here we go. These are my maternal groups. So now I've got a much more useful set of maternal clusters, because if I combine this with what I already know, I can start to identify these clusters much quicker than I might otherwise have been able to do. So that is the first new thing that I've added to chromosome maps. I should add that the big changes to chromosome maps that I'm hoping to do are going to happen after the bustle of Roots Tech. So I hope to be able to report back later this year with some of the bigger changes that I've been planning to do for a couple of years, but I wanted to not leave people with nothing in the meantime. So the next feature within chromosome maps is, again, another thing to try and help managing your map easier, particularly if it's getting quite big. So if you click into import segment data, we have got a new option over here which allows you to import segments just on selected chromosomes. This kind of came from my own need. As you may have heard me say before, I had a Jewish grandfather, and what this means is that just over 25% of my DNA is what they call endogamous, and that means that I've got a lot more matches than maybe a lot of people have, and my father obviously has yet more. So that means that even if I put the threshold reasonably high, I can find I have an almost unmanageable number of segments if I import, for example, a whole file from family tree DNA into my chromosome map. So I thought that maybe the first step for making this easier might be to have an option to just import selected chromosomes. So if I want to really focus in on a particular area of my genome, I can say, well, okay, I'm just going to have chromosome 1 and I'm going to have the X chromosome. and I can import just those at one time. And so hopefully that gives you a bit more flexibility in managing your map. Okay, so that is chromosome maps. What have I got next? Oh, this is just showing you where that tool is in GEDmatch. So if you scroll down to the tier 1 tools, I think we've got the original auto cluster tool, clusters with auto tree, and then we've got auto segment and auto kinship. So those are worth a go. And that's the cluster auto painter tool, which is available under tools. Okay, so now finally we're going to look at trees. I still don't think trees are used that much at DNA Painter, which is a shame because I did a lot of work on them and I'd like you to use them. So here's a couple of ways that maybe I'm making them more interesting and people might like to use them. I'm not sure if you're familiar with the trees or not. I'll give you a quick whistle-stop tour in case you're not. So what we're looking at is the tree view, and I could build this manually or I can import a GEDCOM. I imported a GEDCOM, and I also hid the names of living people so that I wouldn't expose anyone publicly during this talk. And I've got a fan view, and within the fan view I can hover over a node and I can see the path down to me. That's a nice feature. And another nice feature of this is that I can show pedigree collapse. So my mother's got a line where there's a small amount of pedigree collapse, and some people have got really extreme pedigree collapse and they have a very dramatic view here in their fan chart. Then I have a text view of my tree. We're just seeing a few generations here, but I can expand that to more. Another key feature is the tree completeness. So this is something that those of us working with autosomal DNA become obsessed with, because if you have a match and you can't identify them, you have to think, well, should I be able to identify them? You know, how good is my tree actually? How many of my third or fourth great-grandparents do I not know about? What holes are there in my tree that this match might potentially be in? So that's another big feature here. But another way I use the trees, and I think maybe some other people do, is I build out direct lines for DNA matches. So if I've got a bunch of DNA matches who all seem to lead back to one couple, or even if I've just got one DNA match who I think is promising looking, I'll actually just build a really simple pedigree chart for them here. And it was while I was doing that the other day that I thought, well, this isn't quite enough information here that I can see on screen. I'd like to see their birth year and death year at the same time, because otherwise I'm going to get confused about the generations and where our trees might intersect. So over here, there's a little settings cog, and I'm not sure if you've seen there are various different display options. So the default is just to show names. Then we've got haplogroups. So look at this. This is a proper DNA geek out territory, but I'm showing mitochondrial and Y-DNA haplogroups here. And if I was just interested in one or the other, I could show just Y haplogroups or just mitochondrial haplogroups. I can show Ahn and Tafel numbers, which actually for some people is a really useful way of referring to specific ancestors in an abbreviated way. But I have a new option now, which is names and dates. So this, like I said, is just so that at a glance you can see what the lifespan of someone is in a tree that you're looking at. And I thought that was particularly important for this application where you're building a tree for a family you don't know very well, and you want to try and figure out, where you intersect with each other. Okay, so finally, just for fun, I did add some little features to the dimensions area. Now, if you haven't used dimensions, dimensions is obviously not a word that I made up, but it's a word that I decided to adopt to describe different sets of facts which you can associate with people in your tree. So, for example, we have age at death. And I found this a very interesting way to look at your tree in a way that you might not have looked at it before. So if we click into the fan view, we can see that the darker colours are people who lived longer and the lighter colours are people who lived less long. And not surprisingly, most of the people a bit nearer to the present day, they've got darker colours and had longer lives, and maybe they get a bit lighter going back, although you can kind of see a pattern in some other places. I have a great-grandmother who died rather young. So that's one of the existing kind of predefined dimensions which DNA Painter can just build for you from your GEDCOM. So just for fun, I added a couple more, and here they are. So we've got Western Zodiac sign. Now, I'm not into astrology, don't get me wrong. It's just that I saw these dates, and I saw these years in the tree, and I thought, well, what else can we generate from them that might be fun? So here is my astrological tree. So what's going on here? Well, I seem to have an overrepresentation of Capricorns and Virgos. That's what I can tell you, really. Okay, now I've got another one, which is, if we go to add edit dimensions, I've got the Chinese zodiac sign. So this, again, it certainly raises a smile. If you click build dimension here, we can see that, well, basically two goats got together and they made me. I'm the child of two goats. I've got a couple of rabbits up there on my mother's side. You get the picture. So this was actually very fun to build because the Chinese year is different from regular years. The Chinese New Year works on the lunar calendar. And so it was surprisingly complicated to get this accurate because, of course, I wouldn't release this unless it was reasonably accurate. So the only abbreviation I have here is that if you only have a year in for one of your ancestors, I will make the assumption that they were born after the Chinese New Year for that year. But other than that, it's very accurate and quite fun. So you can have a look at who all the horses are in your ancestry. Who are the snakes? Let's have a look at the snakes. Okay, that's the snakes. Okay, so that brings today's presentation to an end. I see I've been on for about 20 minutes. That's good. That's about right. I want to finish without doing a hard sell or anything, but just so you know, if you did want to subscribe to the site at all, you can do that and get a $10 discount if you do it before March the 6th. So just to clarify around this as well, if you are not currently a subscriber, then you can just immediately subscribe and you can get it for $10 off. If you are already a subscriber, then you can activate this coupon basically, which will give you $10 off your next payment. And the only exception to that is if you were one of my much appreciated early adopters who signed up in those first 2 weeks late in 2018. Can't believe it's that long ago now. Then I'm really sorry, but you can't combine the offer. This is mainly because the programming would have taken me a week. So if you're one of those people, sorry about that, but thank you so much for supporting me. And I guess thanks for tuning in this evening. I hope it has been interesting. Leave me a comment and tell me, because I haven't been looking at the screen or doing anything. I don't even know if anyone's listening, except I can see there's a couple of comments there. So thanks very much indeed, and have a brilliant conference. Take care.